submissions.
Thanks, Julian. So my name is Andre, and I'm here to present the technical side to one of the FDA pilots we are working on on the R consortium submissions working group. And the problem we're trying to solve here involves the idea of submitting an R and Shiny application to the FDA. In broad terms, the reviewer should be able to open the application and do their work without having to think twice about setting up R, about setting up the environment, system dependencies, their packages, and so forth. In an ideal world, it will be an identical process to open a PDF document. In the past, we've submitted a teal application uh, with teal application to FDA with pilot 2, and it wasn't clean. The ECTD submission itself didn't have a problem, but there were issues with the complexity of setting up the environment to run this application, with some back and forth with the FDA representatives. If we look at the instructions, they were 5 pages long and quite complex, where you have to set up make and a lot of other low-level applications that we kind of want to abstract from. So we set out to improve on this with two independent methods. And how does that code say? Why build one when you can have two at the price twice the price? And first, our initial approach was to use containers and Podman, the open source alternative to Docker. This was the obvious next step. So we have an application running in a virtual environment that was already set up, and it doesn't require a lot of operations from the FDA reviewers or the FDA representatives. And there are some caveats though, such as having to package the container and ensure that the reviewers can download or build it themselves. The second approach was to fully run it on a modern browser with a new buzzword that was coming out of POSIT and spearheaded by George Stack. It's called webR, and that runs R in the browser via WebAssembly. We didn't have high hopes for this as it was very early stage software a couple of months ago, but it would address one of the problems with Podman. That was the overhead of having a big container file that needed to be submitted or built, which also takes some time. And first, we will take a look at Podman, which was the safe bet and the fast one. This solution requires an installation step to install Podman and pulling the image or building it. Building it takes around 10 minutes, so it's not a very long process, but it still takes some time. And despite this, it fulfills our goals. Like in 99% of the cases, it won't require any troubleshooting or instructions with multiple sections, subsections, as we saw on one of the first slides. And with around 46 lines of code, we can have this container set up or defined with some extra small files. It took us actually more time building the images or setting up smart caching than actually getting this proof of concept rolling and working flawlessly in multiple operating systems in different computers. It's also always a good test to test it in a different computer, and always a success when it uh, actually does the job. So our attention actually turned to webR in this early stage software that was very preliminary, but since then POSIT actually released a newer version on POSIT.com. And first, it was to understand if it is possible to use webR as a way to package a Shiny application, and all of this within a reasonable timescale. To see how far we can do it, if we can do it, and how far we can actually push it. As an intuition about what the technology of webR is, it is a way to compile R and their packages to run in a browser, ultimately leading towards a new platform besides Windows, Mac, and Linux. We can have like the browser as an operating system where R runs in. And it runs R on all desktops, but now it can also run, for instance, on the mobile device. There are a lot of limitations, as the browser cannot do all the operations that an operating system does, but it can get the job done with a Shiny application, as, such as a teal one from the teal family of packages. It also needs a web server running to deliver the app. However, that only requires a Python command or using a native R HTTP UV package. So the overhead is much smaller. You don't have to install like Podman. You don't have to download a big file, or it takes a lot of time to build the container image. In terms of requirements, it is as close as we can have to open a PDF file. There are also some ways to extend this, maybe with Electron, where we can actually just double click and open the Shiny application in multiple operating systems. The problem here is that we don't need to change the R code nor have to compile anything ourselves. We can actually look at this directly in this example. I'm hoping the GIF is moving, but if not, you can. I'm going to paste it a link on the comment section, where you can actually open this live webR deployment, and that runs a teal application. It will take some time to load, as it is like webR currently still has many limitations. One of them is that it installs the package live from a webR repository. So it might take some time, like a minute or two, for the application to load. But after that initial load, it behaves just as an R Shiny teal application that many here may be familiar with, maybe familiar and have worked in the past. This was this first demo was actually the first early on in July, where we are just looking at the proof of concept. But since then, we've done a recent sprint that is fresh off the oven with the latest iteration that by my fantastic colleagues Timek and Pedro, and they did a wonderful job by extending the initial teal application or teal demo to a fully fledged pilot to submission. Running on webR. So with the same application as in Pilot 2, we converted it to run it in webR. And we had to trim down the application that was submitted as the data processing was cached. And there are some teal packages that are not yet available on CRAN. Shiny widgets and Calpot also are still not available on webR repo. So there are some limitations, but it is possible. I'll also paste the link here in the comments, and you can actually open it yourselves. And you can see like there's already like a difference between the two demos, the initial demo and this one, where it is more polished and it gives out some messages of the packages that it is installing. Anyway, regarding these limitations of teal, shiny widgets, and Calpot, we replaced those packages with some shims that replace the functionality. But this allows us to plug in the original packages when they become available. Having all of the packages in CRAN is something that is very important to the FDA at the moment, and for this pilot in particular. And as we can see in the demo, the functionality is fully there. It also has an additional feature that it can run completely offline with a bundle. This is something that POSIT will better support in the future, but it is already possible to do it now, as my colleagues Pedro and Timek have done. And I'd like to end it here. You can actually access the links yourselves and remind that this is unlike other Shiny applications that you have been interacting with, as they always run either on the operating system on your R locally or in a let's say a connect instance. But this one, all of the operations, all of the code, the logic that is in R, it is running inside of the browser. And this is the game changer, as we can package these applications and send them to fully run in an encapsulated system and use them for like some of the use cases. One of these use cases is this one for FDA submissions. And I'd like to end it here, as I've said, And in the working group, we will continue to work on this and eventually submit it to the FDA for feedback and to improve on the process, and also create this new process of submitting Shiny applications to the regulatory agencies. And I'm open. I also like to point out there's a presentation by Eric Nance that will also talk about the current state of the working group and all the wonderful news through all of the pilots, including this one. It's a presentation by Eric Nance, Alexander Lauer, and Rich Iannone, and it will happen on Thursday at 11:40 a.m. So thank you.